So solving equations. So like if you're solving an equation like this equation, 2x plus 1 equals 5. So for something like that, you might subtract 1 for both sides. Oops. There we go. Subtract 1 for both sides. And you get 2x equals 4. Divide by 2. Divide by 2. You get x equals 2. And you probably can almost look at that and tell that x equals 2. If you think about it, this is kind of linear in nature. What I mean by that is if I were to graph this, I think that first graph would be a slope of 2, y-intercept of 1, something like that. The other one would look kind of like this. And where they cross, that point where they cross, the x value of that point would be 2, something there, 2, 5, I guess. I say that to say that usually with linear type equations, you have one solution. But do all linear equations have one solution? Well, that's actually a pretty good question. So you'll have solved some linear ones before. Let's try these and just see what happens here. See if they really do have one solution or not. So if I solve this one, I might, you could try subtracting 2x here. If you do that first, you get -1 equals 1. Wow. I could add 1 to both sides if I wanted to. Either way, this is not looking good. 0 equals 2. I don't think that's actually true. I don't think 0 does equal 2. So if you get two values that are not equivalent, that means there is no solution. So the empty set, if you want to be cool, you could do it like this, right? Whoops, like this. Oops. Why am I missing it? Like that. As the empty set, right? So no solution on that one. So I guess if you look at this graphically, you'd have two lines that have a slope of 2, one with a positive y-intercept and one with a negative. They would be parallel lines. They never touch. This one, let's try to solve this one. So it's interesting. We subtract 2x. Let's do that. Get -1 equals -1. Well, that's true. Actually, that's always true, right? So this is true. And usually what we say, the way we say the answer here is we say if you get two values that are always the same, infinite solutions. So there are an infinite number of solutions. If you look at the graph of this line might look something roughly like that. If I graph the other side of the equation, it would look like the exact same line. How many solutions are there? Every point on that line is a solution. So there's a whole bunch called an infinite number of solutions. So those are the two situations you need to be aware of. It really helps to visualize what's happening there with those types. So be sure to check your work. So let's just solve this one like we already solved. So maybe you distribute there. Everyone's favorite prop 6n minus 24 equals 3n. Maybe subtract 3n, so we get 3n minus 24 equals 0. Add 24. Notice I'm showing my work. It's a good idea to do that. You'll make a lot less mistakes if you do that. Divide by 3. I know I'm getting a little sloppy there. Divide by 3. And you get n equals 8. Well, how do I check my work? How do I see if n really does equal 8? Well, if you plug it back in to the original problem, right, so that would be 6 times 8 minus 4 equals 3 times 8. Well, let's see. 6 times 4 is 24, and 3 times 8 is 24. It checks. That is, in fact, a correct solution. So you can always check your work. It's really handy. Always a good idea to check your work, really. Sometimes it's easier to kind of multiply first on some of these. Like in this case, I could multiply both sides by 6 to get rid of that denominator. That would be really handy there. So we get, I'm going to go and distribute inside of there. So that would be negative 2x minus 14 equals 18. Add 14 to both sides. Get negative 2x equals, I guess, 32. Divide by negative 2. Show your work, and you get x equals negative 16. To be sure, especially when you have denominators, check your answers. You could plug it back in there for x there, and make sure that you have the right answer there. solve this literal equations for h. So this is kind of a strange thing. We're trying to solve this equation for h. We're trying to get h all alone, which means all the other stuff has to get on the other side. You could do this a lot of different ways. Some students would multiply by the reciprocal of the fraction, so both sides get multiplied by 3. If you do that, you get 3v equals the 1/3 and 3 cancels. You get s squared times h. To solve for h, you want to do the inverse operation. So s squared, we're going to divide by that. And so we basically get h equals 3v over s squared. So solve for h here. So this one, pretty similar. I want to get that over to the other side first. So I might subtract s squared for both sides. Those don't play nicely together. So I'm just going to write it like this. Equals 1/2 s times h. Let's try this in one step. So these are both being multiplied. So you could multiply both sides by the reciprocal of that, which is 2. Well, yeah, let's do that step first, and then we'll go there. So this would be something like 2 times, I'm just going to write it like that, v minus f squared. You could distribute if you wanted to. Equals, that cancels, sh. So then you would want to divide by s. Divide by s. If that's a minus sign, those don't really cancel. So you get h equals 2 times parentheses v minus f squared all over s. Let's get to a couple of more difficult cases here. So to solve this for capital R, actually this one's not too bad. It's in one step, right? If we just divide both sides by that parentheses, R1 plus R2, that cancels, and R equals basically that, which is nice. And that's what you're going to have to do here. So this is a much tougher problem. Why don't you see what a really tough problem looks like? The problem is there's R2 there, there's R2 there. So I've got to do some stuff. Let's get both those things on the same side of the equation. So I'm going to distribute this. So R, plus it's confusing. There's just a lot of R's going on. Plus R times R2. I want to say R2D2. R1 times R2. Okay, I got to get both R2 terms on the same side. So I'm going to maybe subtract this guy, get this guy over to the other side. So minus R1, minus R1. So I get, let's see, R2 equals R1 times R2 minus R1. Boy, this is confusing. This is a times here, so I'm going to maybe get this term over to the other side by subtracting it. This is R sub 2, not squared. So I'm going to subtract R1 times R2. Subtract R1 times R2. So you get R, wow, we're almost there. R times R2 minus R1 times R2 equals negative R times R1. Wow. Okay, so I don't know if you see it, but do you see the common term? It's in both terms. We need the R2. It's kind of like a GCF. Think of that like a GCF. So if we do this, this is going to pull out a GCF of R sub 2, which is R minus R1 equals negative R sub 1. Last step, we're almost there to solve. We got it all alone, almost. So if we just divide by that parentheses, we'll have it R minus R1, R minus R1. That nicely cancels. You get R2 equals that guy, that fraction. Whew. Wow, this gets tough for sure. Let's just solve this one and see what happens here. So this looks pretty straightforward here. Just distribute, I guess. So 6x minus 5x. I guess plus 20. Be careful to distribute. Negative 5 times negative 4 is positive 20. Equals 2x minus x minus plus 40, because you distribute a negative there. So plus 20. 6x minus 5x is x. Plus 20 equals x plus 20. I'm noticing something here. you might be able to stop right now and know what's going to happen. So you get 20 equals 20. Well, that's true. This must be an infinite number of solutions. Or actually, we should say, let's say all reals. All reals, I'm thinking about it systems. So even back there on this problem, I would not say infinite solutions. I would say it's all reals. I was thinking about it like a system, but really for one equation, we consider that all reals. Sorry about that. At least I caught it before the end of the screencast, though, right? And that is the end of the screencast. So that was just in time. If you did look at it as if you like both sides of the equation, it would. I was thinking of it like a system, but that's how you do that.